Are you going to help her put this on?
Just need to put on. Yes, would all the presenters please sit up in the front?
They want you up there. They want you.
We've got all of our presenters who are currently present seated up here at the front. Else back there that we're waiting on. Okay, I know we've got a couple people already slipping in late. Welcome, good evening. I'm Dylan Miles Hamilton. I am a volunteer participant with Transition Asheville. Welcome to our water forum. Transition Asheville co-sponsors this event along with Waterlinks, and we thank Lenore Ryan for the use of the space and the WNC UN for also supporting us and co-sponsoring us in this event. So those are some of the folks that are behind this, along with all the organizations and departments and groups of spirited citizens leading the charge that will be presenting with us tonight. So thank you for being here. It shows that you care, and welcome. Transition Asheville is a citizen group, community-driven effort to relocalize and thrive in the face of some of the big global issues that are faced by people all over the planet, but also by people who live right here in Asheville. So the transition movement is a global movement that happens at the community scale, and we are the local chapter. And we are primarily concerned with building community resilience. And so we look at things like changing climate, we look at things like unpredictable weather patterns, the potential for severe storms, floods, and droughts, things like that. We look at energy shocks, instability in the global economy, and we try to build resilience in our community to better face and address all of those issues. And of all those things, within all those issues, water is connected to all of those things. Water is connected to energy production. Water is connected to weather. Our weather affects the water quality, our droughts and floods. So this is an issue. This is the substance of life. Next to air, water is the next most important thing to sustain life, right? And so all the different issues that come up when we start looking at water, we want to address, we want to look at those things, we want to get informed, we want to feel empowered, we want to know who we can talk to, who to approach, how to approach them, who's doing what in the world of water in our region. And so that's why we've called you all together here for this event, called all these great knowledgeable speakers and presenters here. And so welcome. Now, and this isn't just a Transition Asheville production, as I mentioned. We're partnered up with Waterlinks, which is basically Sherry Ingram here. Sherry is a professional geologist. She's a permaculture enthusiast, and she studies the water cycle as a global system, and she's the technical manager of the Linking Waters Project. And we'll get to talk more about that in just a moment. In fact, I think we'll go ahead and talk more about that right now.
Thanks, Dylan.
Introduce Sherry Ingram.
Thank you. So I want to introduce to you the Water Sustainability Initiative. which is, basically promotes 4 things for water sustainability, trying to synthesize it so that it's something that people can understand and think about later. And those 4 things are plants, tanks, earthworks, and community engagement. So here in western North Carolina, we do have some water challenges, some issues. We have flooding periodically. We have droughts periodically, contamination, particularly sediment. And here we also have problems with our political climate these days, so around water. So these 4 simple things can address all of those problems. And I want to show you tonight how that can work. So one thing that has led to these problems and them being so extreme is impervious surfaces. That is places where we've covered the ground with something that water can't get through, like roads or parking lots or the footprint of a building or basketball courts. So because the water can't get through, it's increased the runoff a whole lot, from 10% to 55%, and it's decreased the infiltration a lot, from 25% to just 10% for shallow and only 5% for deep. And that's important because that water that's under the ground is what keeps our streams full. The water table, if the stream is deeper than the water table fills up the stream. But if the water table sinks down, then the water from the stream sinks down into the ground instead of staying in the stream. So that really changes the whole way that water moves in our environment. So here are some sources for contamination. We have agriculture here, some industry, our landfills, roads, and residential properties. The biggest contaminant, as I said, is sediment. And these measures can help us control that problem very simply. So how much water are we talking about? Well, 1 inch of rain on an acre of land gives more than 27,000 gallons of water. So in the worst drought ever in western North Carolina, in 2008, we had close to 37 inches of rain times 27,000 gallons. That's about 1 million gallons of water per acre in the worst drought ever. And I saw that and I was like, I don't think the problem is not getting water. It's what we're doing with the water that we get. So what we have been doing for the past 200 years is drainage. We built little hills to put our plants on. As you came in or when you leave, you'll see that the plantings are up on little hills. And there's an alternative way, is to put them in little gullies. These are also termed innies and outies by engineers. And it's hard to tell for sure because then, you know, the thing is that you need to build them up with mulch. So it could be that those are innies that are filled with mulch, but I really think they're outies. But anyway, so we ask the water to leave and we direct it to the street as quickly as it hits the ground. And then it goes into the storm sewers. The storm sewers are a different system than the sanitation sewers. They're 2 separate systems. When you flush your toilet, it goes through the sanitation sewers to a treatment plant. But when you water your lawn and the water flows off with all of your fertilizer into the street, it goes straight into the creeks and the streams. And the way we've done it for the past 100 years or so, you replace that water from the water system and pay your bill, or you have a well and you pump water that was underground up to the top and you make it into surface water. So here's a different idea, infiltration, which is gradual recharge. So you put landscaping around your house that invites the water to stay. And you fill it with mulch, which holds the moisture. And you give it a chance to soak into the ground. So here, this median strip that you see is planted down. And so the plants there, the roots go into the ground and they invite the water to stay. And this is a good thing because it keeps the soils moist and it recharges the aquifers. So, and once you put some work into this, it's pretty much maintenance free. So that poor guy is just hanging out under his apple tree and he doesn't even have a water bill anymore. So, not that they're that bad. So, here we go. What do we want you to do? Plants, tanks, earthworks, and community. And the thing that I think is really cool about these is that the same features work for drought as work for floods. So they also limit contamination. You keep all of the water that falls on your property, there's no storm water. It's all rainwater. So we're going to look at those a little more. Plants. Well, everybody knows they moderate the air temperatures. Even the cows know that. Don't get into the shade on a hot sunny day. They're the base of the food chain. Either you eat plants or you eat something that ate plants. It all goes to plants. They capture soil, they keep it in place and keep it from washing away and turning into sediment. They capture carbon, so they're a good defense against global warming. They build topsoil. And through the process of photosynthesis, they create oxygen, and they move water from beneath the ground up into the atmosphere, where it increases humidity and the likelihood of condensation and rain. So that in the summer, water moves like this instead of like that. So those are real advantages for us humans. Well, how about tanks? Everybody knows you can put water into a rain barrel and then you have a little bit of water in case it doesn't rain for a couple of days. But the whole idea is to get a tank that's big enough to go from one rain to the next. So I recommend bigger tanks for this reason and this other reason that I'm about to tell you, which is something that NC State has been promoting for at least a year, because I went to a workshop when they were promoting it then. And the idea is when you're expecting a bad storm, then you have the people partially drain your tanks. And then it rains and you fill the tanks, and when it's safe, you empty the tanks. So that can avoid some destruction due to heavy rains. So that tank over there on the lower right is my favorite. It's under the patio there, and in a very dry climate where they need a really, really big tank like that. So earthworks. Earthworks are structures that are made of soil or some other material, and the purpose is to slow the water down and give it a chance to soak in. So here are a few types. Check dams, which are porous and water goes through them. Berms and swales, which are hills and ditches that go along contour and slow the water down. Infiltration basins, which in this situation is usually around plants. and diversion swales that go from where you don't want water to where you do want water. So, and all of these are variations on features that engineers call low-impact development. And they're commonly used in engineering in industrial and commercial applications. But I think they need to be used in residential applications, particularly in cities, because residences are the places where there's not impervious cover. And so if we use the points that are not covered and we invite the water back into the water system, into the water regime, then I think we can counteract some of the effects from paving and pumping. Oops, it's gone ahead of me. Community. So, you know, coming to an event like this is community. Making plans with the people in your water hood, that is your watershed subbasin. And we'll talk a little more about that soon. We have a petition here that when I presented this information to the Asheville Sustainability Advisory Committee for Energy and the Environment, they said, well, show us that people want it. So we have a petition, we have a letter of support that we ask organizations to tell us, tell the city, tell whoever, hey, this sounds like a good idea, let's do this. So we divide our features into low-tech, mid-tech, and high-tech. Low-tech are really simple, almost anybody can do them with just a shovel if you're energetic. Mid-tech, if you're handy, you can do these, but if you're not too handy, there are companies that do them and you can hire. And then high-tech, these are features that have some specialization, like gray water systems. The regulations are changing about that. You need somebody who knows about the gray water systems to at least consult with you before you do that. Rain gardens use special materials. So, so these are some divisions that, these are features that really you should call in the pros and get an example. So one of my roles this evening is to try to make ideas that may not be obvious more interesting and clear. So I'll be doing some simple demonstrations, but I want to start off with talking about our history with water and some earth processes. Earth began forming about 4.6 billion years ago, and evidence of plate tectonics and the early formation of oceans was evident as early as 4.4 billion years ago. To get an idea of how long that is, if you counted the number every second, you would not reach 1 million until 11.5 days. And you would not reach 1 billion for almost 32 years. So the amount of water on Earth has not changed much since about 4 billion years ago. But the atmosphere only became enriched with oxygen after plant life developed about 3.5 billion years ago. However, what stayed constant is the physical processes due to gravity and to heating and cooling. So this includes the water cycle, which is a single global system that can be influenced by local action, in which water is in constant motion due to the heat of the sun raising it up to cooler levels where it condenses and falls to Earth due to gravity. Roughly 97% of water on Earth is in the oceans, a number that is increasing. About 2% has been in snow and ice, which is decreasing. And 1% has been in groundwater, which is also decreasing. The rest is in much smaller amounts in lakes and rivers, the atmosphere, plants, and animals. So when rain hits the ground, it can either travel across the surface or under the ground. Water that moves across the surface moves rapidly, and it erodes the topsoil away, it undercuts plants, it scours and uplifts and transports sediment and chemicals, with the impact increasing as the speed, volume, and distance increase. So water in the ground moves more slowly the deeper it goes, keeping the streams full, plants lush, air mild, and soils moist. You have seen this in action as heavy rains and water drains from the environment, with springs and intermittent streams suddenly springing back to life as a slug of water passes through the whole area. So the French Broad River could actually flood here without any rain because they had a heavy rain in Brevard, and that slug of water is coming through where the French Broad River comes through Asheville. So the way water moves through an area will also combine with gravity, and over time, slumps and slides are inevitable. They're unavoidable. So with that, I'm going to turn back to Dylan, and he's going to introduce our next speakers.
Thanks, Sherry. Everybody who was living here at the time remember the rains we got a year ago, last spring? I mean, it just rained and rained and rained for days, causing flooding problems, causing erosion problems, causing all kinds of issues for everybody. We have a couple of folks, a couple of gentlemen here who are going to talk to us about some of the factors and issues and concerns around excessive rains. And so first I want to introduce John Haas. Is that how you pronounce it?
That's correct.
And John Haas is a member of the Friends of Town Mountain. And the Friends of Town Mountain is a group formed to educate on environmental issues and promote responsible development along Town Mountain Road and surrounding communities.
Good evening. As he said, we cover Town Mountain Road and all of the roads that connect to Town Mountain Road, down from College Street all the way to the Blue Ridge Parkway. Well, last summer, I think how many in here were impacted by the heavy rains? I know, yeah, look how many people. Well, we certainly were impacted in our community. In fact, Town Mountain Road collapsed. We had a landslide, and so we lost the use of Town Mountain Road. That makes driving and getting to our homes really difficult. You got to use the Blue Ridge Parkway or Webb Cove Road. We also had memories of stories about that home in Beaver Dam that came down the hill and that had to be demolished. We also had a swimming pool and another house just below Town Mountain Road in the Sunset Grove Park area that also started sliding down the road. They were condemned and had to be torn down. So the excessive rains really impacted our community. And we came together as a community to try to address those concerns and do something about it for the future so that it wouldn't happen again, or at least to mitigate as much as we could. With me here tonight is Dr. O'Kane, who really took the lead in our community in finding ways, what can we do here in the future? Well, what we discovered was there are natural paths for the water to flow. And as you heard earlier, the water that flows across the land instead of underground, it picks up speed, it comes down the hill, it gets bigger and bigger and causes more and more problems. So what we wanted to do when we found out that the water didn't follow the natural streams during the excessive rains, we said, why is that? Why is it going across our pavement? Why is it flowing across our yards? Why is our houses going down the hill? So Dr. O'Kane took the initiative to look at this and found out that many of our drainage ditches and culverts where the water would naturally flow to the streams were all blocked up. There was no maintenance of them. The city, the county, the state, nobody took care of them. So Dr. O'Kane took the initiative to build the relationships with the city and the county and the state to identify all of the culverts that go underneath the roads And we were able to do that in the city. It was fairly easy because in the city, all the culverts that go under the roads are all on the GIS system. So we can get a big map, even though you can't see where the culvert is and the drainage ditch, we can pull the map up and come pretty close to finding that exact spot and then marking it so that the city can exactly see where it is, and then they can take responsibility for getting it cleaned out. In the county, unfortunately, since it was not in the city, the drainage ditches and culverts are not marked. So we had to walk Town Mountain Road, and it was a community effort. The community came together to identify where all the culverts were, marked them with stakes, so that we could then identify those to the state. When we have a drainage ditch culvert that's blocked, we can say, hey, it's the white stake that's next to 842 Town Mountain Road, so that they can see and know where to go to clean it out. We also enlisted the help of our community. If you have a culvert that's right next to your house and you see that's been marked and you see all of a sudden we've had a heavy rain and now it's filled in with a lot of debris, take a little initiative, go out there and clean it out, kind of help yourself. Because it's what we're into our intention is to try to prevent it from happening again, or at least mitigate the circumstance from happening again. The other thing that I think we learned from our experience was, one, is that you really need to build relationships with city, county, and state government people. And when I say a relationship, I don't mean just picking up the phone and calling and complaining. You got to sit down and meet with people. You got to get on a first name basis. And when they do a good job, when government does a good job for you, you need to make sure you let them know about that. Because that's how you build a relationship. It's not only about complaining and trying to get services, but when they really come through for you, you want to let not only the person that's done that for you, but then their supervisors and maybe the political people. Because that's how you build goodwill and you make that partnership between government and community. And that's what we found to be most successful. I can pick up the phone now, and I'm on a first name basis with the top engineer with the North Carolina Department of Transportation. If I got a problem on Town Mountain Road, I've got somebody that he knows, that he's worked with, that we have a relationship, and you're more effective that way instead of just some anonymous citizen picking up the phone and complaining. So that would be my other recommendation to you. Finally, the other thing that we did is we got Rick Rudin come do a presentation to our entire community to talk about excessive rainings and runoff and drainage and the importance of trying to prevent the landslides from happening in the first place.
Thanks, Ron. Should I advance the slides? Okay. All right, thanks, John. I appreciate the introduction and also appreciate very much what you're doing, because what I'm here to talk about is when we have too much rain. So, this is the other end of the spectrum from droughts. And it's a natural phenomenon here in the mountains of western North Carolina to have landslides, because rainfall, heavy rainfall, is one of the things that triggers the landslides. And so what I'm going to talk about is when we can expect them to happen and what the frequency is, where to look for them, where they might likely be to occur, and some things you can do as a homeowner to be prepared, be aware of your surroundings, to know if you're in a tenuous spot. So you're not in a position where A, you lose your house, or if the road to your house is washed out, you can anticipate when that might happen and you can be a little bit better prepared. Have things stored up, water, have alternate routes planned, those kinds of things. And so, to start with, I'm going to move along pretty quickly here. This is actually a graph that shows time here, and this is the amount of rainfall. And for each one of these blue bars, it records the amount of rainfall over here. Those are events we've had since 1876 that have triggered landslides. So the bottom line is it's going to happen again regardless of climate change. Looking back to 1876, there have been at least 21 landslide events, fairly major events, and undoubtedly more. So we can expect one in this area at least every 5 to 6 years. And so I can't remember really many years since I've been here in Asheville, since 2003, when there hasn't been a landslide somewhere some year. So it's pretty much an annual thing. I think that two big things that come out of this graph and looking at it is from 1916 to 2004. 2004, 10 years ago, is when Francis and Ivan came through. Lots of flooding, lots of landslides. And then a storm that was even bigger than that was in the middle of July 1960. That's a storm of record for the Prince Broad watershed. That is this guy right here. That's actually the record rainfall from North Carolina, 22 inches in 24 hours. So that was a biggie, probably bigger than Francis Island in terms of the overall impact. It's just that there weren't that many people here. There weren't that many people living on the hillsides. So, but what happened in 1916 and 1940 and 2004 out here, we had storms in succession, what we call back-to-back storms. So that's the scenario we really need to be mindful of here in western North Carolina. Because the first storm can come through and it can be big enough or not big enough to generate a lot of landslides, but it makes the moisture conditions in the soil much higher. And then when the second storm comes through, then kaboom, then we have a really exacerbated problems. So that probably would happen, once every 29 years, almost once every generation. But if you look at the storms that have come through since 1916 to 2013 of all types, whether they're tropical cyclones, hurricanes, or just big low pressure systems, it's about one every 19 to 20 years on average. So, the average, each generation can look forward to, or backwards, or hide from one of these events, probably 3 or 4 times in your lifetime. So it's something that's, it's going to happen. So the idea is to anticipate it and be prepared. And so part of what our work has been is to map where landslides have occurred. And in North Carolina, each one of these red dots is a landslide occurrence. And we talked about the heavy rains of last year from January through July. Those are the blue dots. Those are just some of the ones that we looked at. There are probably over 300 that were triggered by that series of storms with an above average period of rainfall during that time. And this is western North Carolina here, and all these little areas that are outlined in different colors are areas that were affected by landslides in each of these different storms going back to 1916 through 2004. And so the basic idea here is that sooner or later in the mountains, you're going to be impacted by a storm that's going to be big enough to trigger flooding and cause landslides. So one thing to point out here is this is Watauga County. And you're wondering, well, why can't I see Watauga County? Boone is down there, App State is down there under all those red dots. In 1940, the storm came through that triggered about over 2,000 debris flows and landslides in Watauga County alone. That's probably fewer than were triggered in the 1916 storm in July. It's just we don't have the records. And so when we were doing the landslide hazard mapping in Watauga County, we had aerial photography that was flown in September of that year. So we're able to see those landslides and record them, get them into geospatial record. And so that's why all those red dots are right there. Undoubtedly, that storm triggered a lot of debris flows in this area of the Blue Ridge Escarpment here as well, and the neighboring Caldwell, Wilkes, Ashe, Allegheny counties. So as bad as Francis and Ivan was, or were in 2004, it's been worse. Okay, so that's the other lesson here is, it makes a lot of sense to be prepared. To anticipate these things so that we can be resilient when they occur, and best of all, to try to avoid the problems to begin with. And looking at this is going to take a look at some of the damage that happened in the storm of that period of above average rainfall, which started in January of 2013. So everything along this line is considered normal rainfall, and everything above that is above normal. So you can see we were nearly 70 inches, 72 inches of rainfall in September, and our normal rainfall is about 45 inches. It's almost getting close to double. So each one of these little steep steps on this graph here is when we had a storm, all embedded in that period of above average rainfall. And the ones with the red arrows are ones where we know landslides occurred during those storms. Definitely in the January storm, and definitely in the July 4th storm around here. Those were big events. The ones with the D, those were federally declared disasters for flooding and landslides. So this is a situation. It was not a tropical cyclone. It was a series of storms within record above average rainfall. So that's the situation that set the stage for some of these events. But let me talk a little bit about.
Can everybody see the presentation, or is it better if we, is that better?
Yeah.
Okay. Sorry.
So how does water work on the hillsides to trigger debris flow? So things have to be in place on the hillside, the causes, the predisposing factors, the steepness of the slope, the soil type, the topography and how water moves on the hillside. So where debris flows, what we call the kind of landslide like a mudslide or a mud flow, it moves very rapidly. Typically start up near the ridge top on a hillside in a little swale or depression we call a hollow. And that's where soil accumulates over geologic time. And when the right storm comes along, that infiltrates and it builds up that shallow groundwater between the soil layer and the hard bedrock. And so the soil moves, the rain moves through the soil rather easily. Compared to bedrock, it hits the bedrock on the way down and it slows down. It starts to build up. And so that shallow water table increases, and that increases the pressure on the soil, pushes the grains apart, and it overcomes the strength of the soil, and it begins to slide down the hill. And then with enough moisture, it basically liquefies and takes off down the hill very rapidly. And let me back up. And so this is what happened at Peaks Creek in Macon County in 2004. This is Fishhawk Mountain. So this is the area where the debris flow started. This is bedrock, you can see on the surface right there. This is the path down the hill, and it traveled about 2¼ miles all the way from the top of Fishhawk Mountain to the Palisades River. And along the path down below in the flat areas where the residents lived was where the damage and the fatalities occurred. And this is one place along the path here where you can see all the boulders and the large woody debris carried by the debris flow. They move very rapidly in excess of 30 miles an hour. The discharge, the amount of water that goes by, and sediment is on the order, in this case, of about 70,000 cubic feet per second. And to compare that to the French Broad River, a 100-year flood of the French Broad River at Asheville is about 40,000 cubic feet per second. So it's not a huge amount of material, but it's going very fast. These are some of the boulders that are transported by the debris flows. These are probably on the order of 16 tons. There's one of our geologists for scale right there. So they're very rapid. This is something our job is to stay out of the way, basically. In other words, don't put ourselves in harm's way. And there's some things that we can see on the landscape that help us understand where these start and where they might end up. So this is kind of the hollow that I talked about. It's called a generalized conceptual model. That's geology speak for cartoon. So this is a hillside. It's kind of a low spot, and that's probably because of some fracturing or differential weathering in the bedrock that's caused a low spot in that contact between the bedrock and the soil. So this is an area where when we get heavy rain, the surface water and the groundwater accumulate, and it builds up that pore water pressure, and then it takes off down the hill along a stream channel usually, because debris flows are water driven, so they go where water goes. And over geologic time, that material builds up at the bottom of the hill in a feature we call a debris fan. And those are all over the mountainsides here. Most of the coves around here are full of debris deposits. So it's something that you can see on a topographic map, and on the areas where we've done landslide hazard mapping, we've identified those. And a lot of times, when you look in these hollows up here on these steep hillsides, you can see the trees are sort of curved like that. Well, that means the ground is creeping slowly already, that slow process of gravitational movement. So that soil wants to get down the hill, and it's going very, very slowly until the right storm comes along. So if you're on a hillside and you see a lot of trees that have that bent shape like that, that tells you that that soil is already creeping downhill, because a tree wants to go straight, right? And so if the soil moves and it leans a little bit, well, it wants to correct and grow straight back up towards the sunlight. So that's what's going on the hillside there. So there's things in the topography and the vegetation that can tell you those places where these kinds of landslides might start. So why do we need to be careful of these places? Well, here's what the inside of a colluvial hollow looks like. And the reason we get to see the inside of it is because it failed, mobilized into a debris flow. This is where it started. It crossed the stream and demolished this house right here. This is one in Maggie Valley in 2009. So under a natural process, these hollows will fail, and then the soil begins to creep back in there. And under natural conditions, it probably takes hundreds, if not thousands of years for that to reload and to fill. The right storm comes along with the right soil depth and it fails again. But if in the process of altering the landscape on a hillside, we pile soil material in that low spot, because it's kind of a convenient spot nearby, and we want to make it level, we can actually accelerate that natural process by loading that colluvial hollow faster than it would in nature, and actually predispose that hill slope to fail sooner than it probably would under natural conditions. So this is a place to look out for when you're building on a hillside. One thing to look at is the steepness of the ground. That's an important factor. When you looked up the landslides, we were plotted the numbers of landslides. I think there are about 300 or so that we looked at here. I looked at the slope of the ground in degrees. You see all the bars take a big jump, whether it's a landslide on natural ground or modified ground or some combination. When you get about to 20 to 22 degrees there, that's when you see an increase in the number of landslides. So that's about, there are lots of ways to measure slope here. So 22 degrees is about 40%. And in engineering speak, it's about a slope of 2.5 horizontal to 1 vertical in run over rise. So that's another confusing thing about slope. There are lots of different ways to portray it. But when you get up above 22 degrees or so, that's when you have to start thinking about, when landslides might occur. So, and this is the case on Black Oak Mountain and Beaver Dam that John mentioned, where the house failed and had to be demolished. Well, this is a slope map here, right? And so the flatter slopes are in the blues and the greens, and that's where the house is, right there in that green area, which is pretty flat. This is the drainage coming up to where the house sat. And you can see all these red colors going in the drainage. It was very steep. So basically, you have to ask yourself, well, this house was sitting on a pretty flat slope. Well, why did it fail? Well, it comes down to why that slope was flat. Because actually, where the house was built is on top of one of these hollows. And it was filled in to make it flat. And so that basic landform was there in order to make a flat pad for it. If you put fill in and don't do it correctly, because you can build a fill and engineer that so it actually would be more stable than it would be naturally. If you excavate down the bedrock, get the right drainage in there, you'd actually be improving the situation. But if you just dump the dirt in there, you don't compact it, you don't provide the right drainage, then you can end up losing your house. And you end up blocking the road here for the other people that live up the hill. Like John said, you can't get to your house for a week. That puts a big crimp in your style, especially if there's an emergency, especially if somebody's house catches on fire. And so not only did this person lose their house, the homeowners association had to foot the bill to clean this up. So that's a big impact on the pocketbooks. It's something that, the right engineering done in advance probably could avoid this. So how do we know where some of these things might fail? This is the failure on Vance Gap Road. You probably heard about that. It was a pretty big deal here in Asheville. A lot of people couldn't get to the house. And it's a road embankment. It failed right here. And it's this spot right here. This is after the repair. Well, this is a stability index map for just a little section of Buncombe County. It's one that we prepared for the landslide hazard maps for Buncombe County. So the areas that are potentially unstable in these heavy rain events are shown in purple and red right there. So this spot on the road is right in that red zone right there. So these maps are not designed to show where roads will fail. They're designed to show where natural slopes under these big rainfall events could be unstable. Not that landslides will occur in here, but if they do, they're more likely to occur in the red zone. So if you have this stability index map, which is on the Buncombe County website, and you look at that where the roads in your neighborhood have that red on it, those would be places to zero in. Do we have culverts that need cleaning out? Are there cracks in the pavement that indicate that that slope is failing? So it's one way to help zero in on where you might have problems. And this is the example at Town Mountain Road that John was talking about. So it's that spot right here. This is a spot up on Patton Mountain Road. This is the governor's western residence. So you can see the cracking in the pavement here. It's been patched and some undermining, and it's right there in that red zone. So that's a spot that, now the DOT and now the city of Asheville know about, because that's a potential problem area. And we don't want the governor to either get trapped up there or not be able to get there when he wants to. So, okay, that talks about where they started. Where do they go? Well, this is what a debris fan looks like on the ground right here. This is a big gentle slope. This is in Maggie Valley. So the area outlined in green sort of corresponds to this spot on the cartoon right here. And the area in yellow is this big concave area on the hill slope that was the source area for all this material over geologic time. Multiple debris flows, lots of debris flows. They build up, and if you look at a cut in there, you can see these old ancient boulders that are in this, swimming in this matrix, this soup of sand, silt, and clay, and these boulders have now decomposed to where you can crumble them with your hands. So these are very, very old deposits in part, but some of them became younger deposits as they moved down along the sides and through them. So this is a place where if debris flows happen, and where the material is probably going to end up. And that's what we see in Starnes Cove. 10 years ago, in September, in Ivan, September 16th, these are debris flows that started along road embankments and cut slopes that merged into one and went down into the Starnes Cove community and demolished this house right here. This is on the way down. This is the mud line in the tree right here. And Rebecca's about 5'6". And so you can see the height of that mud debris flow torrent going down the hill, and it flipped this house and demolished it. So if you look at the stability index map, each one of those started in the red zone there. And the other thing to point out is this area in orange here, these are the old debris deposits that were already there before these debris flows. So they still want to drop that material down in the bottom of the valley where the older debris flows did. And so the other thing to look out for these big debris deposits, sometimes they can be they can become unstable in and of themselves because they're a thick accumulation of boulders, sand, clay, everything that's accumulated at the bottom of the hill. So this little area right here is a slide that started in the spring of 2003 within one of these big debris deposits here. And it's this area that's outlined right here. It's about 800 feet long. And it started moving, and the fellow that lived there was trying to drain it, so he dug a ditch across it. At one time, this ditch lined up with this one, but this one's moving down. So that displacement there is about 5 feet, and we went back last summer, or this summer, that offset is about 20 feet. This is at the bottom of the hill where it's pushed up. The tow material is actually bulldozing over the slope at the bottom of the hill. And so this became a pretty big problem for this gentleman here because his house is sitting on it. So this is a scarp or a tension crack in the ground where the ground's actually being pulled apart. So he was fortunate enough to have the wherewithal and the property to pick up his house and move it off the slide. That's a huge expense. We don't want to have to do that. And this is the top up there where the scarp is, these red areas where the ground breaks. And you can see this bouldery material here that's very typical of these debris deposits. So they're pretty easy to recognize on the ground. So getting close to the end here. So when we have rainfall, it's important for the total amount of rainfall, but what's probably more important is the rainfall intensity and duration. How hard it rains, for how long. So if we looked at Ivan in 2004 in Macon County, where we happen to have good rainfall records and we know the timing of the debris flows at Peaks Creek and several there, it had rained about 1 inch per hour for about 4.5 hours. That was within Ivan. Remember, Francis had been through before, so it was already really wet. So in that kind of scenario, throughout western North Carolina, we know there are about 400 landslides of various types that were triggered by Francis and Ivan. The Watauga County storm in 1940, it was almost 1 3/4 inches per hour for 6 hours. So when you get rainfall that intense, you're probably looking at thousands and thousands of debris flows within a fairly small geographic period. The historical record in the Southern Appalachians is Hurricane Camille in Nelson County, Virginia in 1969 when it tracked over the Blue Ridge there. In Nelson County alone, there are almost 3,800 debris flows. 150 people died. And there it rained 3.5 inches per hour for about 8 hours. So that's the mother of all storms that we're aware of in the Southern Appalachians. So let's hope that doesn't happen here, or anywhere else for that matter. So what can you do? If you're a homeowner, you've got a piece of property. Well, like Sherry's mentioned, it's very important where the water goes and how we manage it. So if your home is built on fill, where they took the soil out of the hillside and piled it on the downhill side, you want to be really careful where your gutters drain into that. Because if the gutter downspout works fine, it's not plugged up, that line isn't broken, it gets the water off the slope, on the safe area, things are okay. But if that's not the case, you don't want to walk outside one morning after heavy rain and not be able to find your backyard because it's down the hillside. The other thing that's really important is vegetation, to reemphasize what Sherry said, because trees, deep-rooted vegetation, have an enormous stabilizing effect on a hillside. Not only are those roots strong, and that's part of the analysis you do when you model the stability of the hillside, the evapotranspiration, it pulls up the waters and helps moderate that moisture in the soil. So you've got a steep slope, and you've cut the trees off, you're tipping the scales towards the unstable side. And if you're making fills, throwing logs up against a tree and then piling the dirt up against that, that's not a good long-term engineered solution. And, okay, last slide here. So some basic ideas, watch where you build, watch how you build, and be aware of your surroundings, on the uphill side and the downhill side, because the laws of physics don't stop at property boundaries. So you and your hillside neighbors are all interconnected. You're part of the waterhood. So what you can do on the downhill side can affect people uphill from you and downhill from you. And that holds true for everybody on that hillside. So the community involvement, like John was talking about, is very important. And you can anticipate these excessive rain events and be prepared. Because they're probably going to occur again. We get a good warning for these tropical cyclones, but when these summer thunderstorms pop up, we may not have a week. We may only have a matter of hours. So just keep that on the radar. Mind the water and mind the plants. Those are all important things on keeping that hillside stable. So I'd like to answer any questions. I know we're running a little over time, so I'll hold off on that and turn it back over to Sherry.
Thank you, Rick.
We'll have some time for discussion at the end, too.
Yes.
If folks have questions. Yes.
Okay, so water can be destructive, and what can we do to protect ourselves? Well, I have some demonstrations here to help you visualize that, and my capable assistant, Abby Holt, who is a water maven here in Asheville. And we're going to start off with this as a representation of a watershed. Now, a watershed is an area of land that has a ridge around it. So the French Broad River watershed has a line of mountains that continue and embrace all of the water flowing down into the French Broad River. In the back is a model of the North Fork watershed. So the French Broad River watershed is divided into subbasins. So the Swannanoa River, for example, is part of the French Broad River basin. And Humley Creek is part. It's a subbasin of the French Broad River watershed. But those divide into finer and finer entities. So Haw Creek is part of the Swannanoa River subbasin. And you can get to a subbasin until it's just you and your neighbors that share a watershed subbasin that all flows into one water body. So that watershed has a capacity of what it can hold. And it makes a big difference. How heavy has it rained? How long has it been raining? How wet was the ground when it started? Did the sun come out today? That sort of thing is complex. But this is going to represent a watershed. So here we have a storm comes along and rains into, this isn't going to work. And here we have raining into this watershed. And it's just going to keep raining until the watershed is filled up. And at that point, things are going to start to fall out. And you're going to have slumps and slides. So what can we do about that? Well, as I told you before, here's an idea. This represents the same watershed with a bunch of tanks with a bunch of tanks that have been installed. Now, if you're gonna install tanks, you wanna install them, you can start. You wanna install them the highest place first. Because if you have a problem 2/3 of the way down the hill, and somebody uphill from you captures the rain, then you don't have a problem. So the higher, the higher up you are on the hillside, the better it is. This is one reason that it's important to try to work with your neighbors and your water hood. So, to coordinate what you're going to do, if you're going to make some changes to try to make the most bang for your buck, is to have a good plan that includes a lot of people in your watershed. So that's one thing. So here's another thing. I have a couple of dry sponges here. I'm going to throw one in here and make sure that it's damp. And now I'm going to put them both in the water and take them out. And I have here, this is the damp sponge. And let's see, it made about half a cup.
Like about a little less than a third.
Okay, a little less than a third. So here's the dry one. A lot less. Our soils are like this. The water can't get in under there. It's like a barrier. And when water's moving quickly, it erodes the top part of that and turns it into sediment that washes down the hill. So if your soils are kept moist, then they hold more water. They can absorb more water. So keeping your soils moist is a way to counteract damage when you have a heavy rain.
So it's basically dry soil that's baked in the sun would be just like asphalt, almost like asphalt.
Yeah, except that it also has a lot of sediment that, can go into the area. So here I have 2 containers. This one has moist soil in it, and this one has dry soil in it. So I'm going to put this here, and I'm going to pour a cup of water in here. And then we're going to see how much water came through. Well, not really very much. So now I'm going to pour the water through this dry sample, and almost all the water came through. So if you do anything with plants, you've had pots like this, and you know that you have to break it up and moisten it and break it up some more in order for the water to soak in. So the moist soil is going to be a better choice. Okay, so now I have 2 cups full of water here. And I have these 2. This one has a plant, some plants in it. This one does not have plants in it. So I'm going to pour a cup of water in here with the one that doesn't have any plants. And so there's the water from the one without a plant. The Julia Child's water. Oops. Yeah. Now I'm going to pour the same amount of water in here with this one that has a plant. Now, not that big of a difference in this little pot, but it does make a big difference on your property. And, you know, one of the functions that the plants do is hold the soil. So if you have an area where it's bare, put some cover crop out there to start with. I'm going to talk a little bit about check dams. Those are a good solution too. But when you have that established, put in some other kind of ground cover. The goal is to get trees, because trees are deep rooted and they hold a lot of soil and they can defend us and they can help with global warming and they can feed us and be great. So with that, I'm going to stop and hand it back over to Dylan, and we'll have some more presentations.
First off, let's give a hand to John Haas. For empowering us and inspiring us to get together, meet our neighbors, build community, and form solutions together as a group. And also to Rick Wooten for informing us. A lot of great information in there, a lot of science to form the foundation for so much of it. And thanks to Sherry, who will be coming back several times probably. Now, if you live in Asheville and you pay a water bill, and you have the luxury of being able to turn a faucet and have water come out that is drinking quality, then you might want to pay attention to the next couple of presenters who are going to be talking about the municipal water system and the water system from the perspective of we, the consumers. So I would like to introduce first Ivan Thomas, who is the operations manager at the Department of Water Resources in the city of Asheville. Ivan.
Thanks. How are y'all doing?
Good.
Good. I think Sherry's working on getting my presentation up here. Are you having a problem? Let's see, I brought another flash drive. Let's see if we can, hopefully, we can send the presentation up. Hopefully get it up. If not, we can talk about it anyway. All right, very good. Well, as, what's your, I'm sorry. Dylan, sorry, I went to call you Jason for some reason. As Dylan said, who's not heard of there's a, general legislatures wanting to force this merger with the water system? I'm assuming everybody in here has heard that. And what Sherry's asked me to do is provide a history, go back and provide a history. And I went back to the 1920s to start, because that's really when things started separating city, county, Sullivan Acts, all that stuff you may have heard. And in 1920s, the Bee Tree Reservoir was built. Who knows where Bee Tree is in Swananoa? About a 500 million gallon reservoir, lake reservoir there that we pull water from, and right now we're supplying about 2 million gallons a day out of that water reservoir. Okay, with a capacity of up to 5 to 6, maybe 7 on an extreme day. During that time in the 1920s, the county outside of the city formed water districts. And these water districts basically ran water and sewer districts, several different districts. I don't know how many there was. I've heard 6, I've heard 7, I've heard a little different stories on that, so I won't speak to that. But during the Great Depression, those water districts went bankrupt. And the county stepped up and said, well, we'll take the debt. We'll take some of the debt over for those water districts. At the same time, the city also took a proportionate amount of that debt from those water districts to be able to to run the water system, serve customers, and do the right thing. So I view it as almost the county and the city as doing the right thing back in the 1920s. 1930s came along, and the original Sullivan Act was born. Billy Sullivan, a legislator at the time, wanted to make sure that the city could not charge differential rates to folks living in the county. So that was passed, that went through. In 1948, and in the years prior to that, population explosion happened. Water drought started happening. Peachtree Reservoir started dropping. There's a picture back here with an explanation at the watershed model that we brought. In the picture frame, it shows Peachtree Reservoir with 2 feet of water in the reservoir. Pretty extreme conditions leading up to that. At that time, the city decided on this 20,000 acre watershed to build the Burnett Dam, Burnett Reservoir, North Fork. What we know today, what I know today is just simply North Fork. 6 billion gallons of water, located in almost a perfect place. I still say today, whoever had the foresight to build that where it could catch all that water in that watershed and reservoir, and not and have minimal drought conditions over the years, was a very smart person. Had some real forethought there. Can't get it to work?
No.
That's okay. We'll just swing it. So, past that point, in 1950s, at some point, and I'm not sure when, the city decided to try to charge differential rates in the county to those outside the city limits. Sullivan Act came up, the city was sued, didn't hold up. So that you kind of have to realize that to understand where we are today. And in the 1950s, that's real important. Weird scenario we're under is you have all these cities in North Carolina. I think Cary is the most extreme case. But there's over half of the cities with a population density like the city in Buncombe County that serve water that do charge differential rates to outside their corporate limits. So we are kind of the exception that we can't even go that route because of the Sullivan Act. And the city has no intentions of doing that to the folks in the county. 1981, we're going to fast forward to 1981. Regional Water Authority was formed between the city and Buncombe County. The city still operated the water system, but we'll fast forward to 1995 now. Henderson County joins the Water Authority. Henderson County, everybody was getting along good then. Henderson County, Buncombe County, City of Asheville. The hard thing about it was you had 3 boards, had to approve a water budget, had to approve CIPs, had to approve operating budgets, you name it. My recollection, I've been with the city for 18 years. The city's been very good to me. My recollection was it was in early 2000s, just really when I started getting into the management roles, it was very hard to get those boards to agree on projects. It was very hard to get those boards to agree on budgets. That's my recollection. So in 2004, the city, by a clause in the Water Authority agreement, decided to end the Water Authority. There were some hurt feelings from Buncombe County, from Henderson County. That's my recollection of the situation. Didn't directly deal with it, but that's just my recollection. The director at the time, David Hanks, would kind of feed us information, and that's how I got my recollection. So, see where we're at here now. 2005, after the Water Authority was rescinded, the Sullivan Acts 2 and 3 come up, set the rate structure to make sure that everybody in Buncombe and Henderson County were not charged differential rates anytime in the future. I'm still under those laws today, Sullivan Acts 2 and 3. Guaranteeing water if it's available. That's another thing the Sullivan Acts had to do, or said we have to do. So if a developer comes in, no matter how high he wants to build, or no matter how many pressure zones he wants to build, if it's available, we have to give that water. Okay, so that's where we are today. And in 2013, or 2011, and Beth's going to talk a little bit more about how those developed, I think, here in a minute, right? The 2013 House Bill 252 passes legislature, meaning that the 2009 legislature where the city could use 5% of water funds for streets and sidewalk projects related to water projects could no longer be used. Okay, that still stands. That bill was passed. House Bill 488 passes legislature shortly after. So that's the one that forces the merger. Passed right through, no problem. City decided, as we know, lawsuit, May 23rd this year, court hearing appeal. I don't think I'm telling y'all anything you don't know, so I'm moving kind of fast. So city wins the court hearing. That was on June the 9th. On July 8th, the state appeals the decision. So that's where we are today. You know, we're still in the waiting mode. I can say from history that I truly believe in our organization, truly believe in the Water Resources Department in the city. It's a good organization. Work with folks at MSD on trying to coordinate CIP projects and make sure we don't tear up streets 2 and 3 times and that sort of thing. They got a good organization as well. Not saying, I don't think either us nor the folks at MSD wanted this situation. Talked to our legal team yesterday, and they're thinking it's going to be about a year before we really know anything on the appeal. So this keeps dragging on, and who knows where it's going to go from there. I wish I had a PowerPoint because I did have some pictures about some of the things we were up and doing, and to show you guys that I feel the water system's in the right hands. You know, since 2004, 2005, we've spent a little over $90 million on CIP.
What is CIP?
Capital improvement programs. That's plant upgrades, water line replacement, automated meter reading, that sort of thing. At our mission and vision, one of the things we say we're going to be is innovative. And when I mean innovative, we're automated meter reading, where we can drive down the streets and read the meters, lessen our carbon footprint, get on the city council's goals and objectives, do things. Who's heard of the Asheville Way? City core values. We try to tie those projects back to the Asheville Way to have a core value that for what we do things for. So, what else is there? I'm going to show you on the PowerPoint. Next 10 years, we have, I think, close to $125 million in capital improvement projects scheduled. Includes plant upgrades, a lot of major line work. Right now, we're doing taking bids for what we think is going to be about a $6 million project to redo the tunnel underneath the dam, the intake tunnel, because it was built in 1954, the final, and it's got some water seepage and where the raw water line comes through and feeds before it's treated. Trying to think, what else? Let's see. 146 employees, 6 divisions. This kind of gives you an idea of how much work we're doing. Customer service division. Those folks answer for customer service for city. The majority of it's water related. Those folks answer 135,000 phone calls a year. Send out 336,000 bills a year. Do the billing for MSD. Handle that well. I think, that just a lot of work. Fix over 1,000 leaks a year in our water maintenance. Over 300,000 meter reads a year. we don't estimate bills unless it's an extreme case. One recent example I wanted to bring up, who heard of a potential water issue in Black Mountain? Anybody recently? We had a potential water issue in Black Mountain. Had a couple folks call and say they were getting sick because of the water. Small neighborhood. We basically went in, had to cut the water off as a precaution. Didn't know if the water was bad or not, didn't know if it had bacteria test come positive or not. We're waiting on tests, We're waiting on cryptosporidium test, which is a waterborne pathogen that can make folks sick. All the tests came back negative. But before then, we went in and cut the water off, installed a line around it, super chlorinated the line. During that 12 to 18 hours, those folks were out of water. We gave them ice, we gave them water, we gave them gallons of water, we worked with NC Dean, Don Price. I don't know if you know Don or not, but we tried to do the right things, even though it's a small community. It's in Buncombe County, but it's in the town limits of Black Mountain. So I think that's why we're still a regional water system in my mind. We don't, even though because it says City of Asheville, doesn't mean we're not going to do the right thing. With that said, I think that's about all I had.
What was it? Cryptosporidium?
No, it was nothing. Ended up nothing. All tests came back positive. Sorry.
All right, thank you, Ivan.
Yeah.
And next up, we have Beth Jezik of Save Our Water WNC, which is an organization and an informational site about the legislative attempt to remove control of Asheville Buncombe's water system from the city of Asheville, and to take that precedent to other communities.
In the program, I believe, if you have underneath my name, you see there's a different website listed under Beth Jezik. I think that might be the site for CTS activities perhaps. The correct website, Dylan just mentioned, saveourwater.wnc.com. And we are a group of like-minded people who are concerned about the disposition of Asheville water. Having gotten involved in this about 3 years ago with some like-minded people, we began to do research on what it would be like if our water, the city of Asheville water, were to be controlled instead by a regional board. We decided to put together this group called Save Our Water. And what we learned, we found to be rather distressing, which really came to our point of view that we are obviously against turning control of Asheville's water over to a regional board. One of the first things that we learned, of course, is that the members of a regional board are not accountable. With our water today, if we're unhappy with the way things are going, we can simply go to city council and tell them we're unhappy, and if they choose not to do anything about it, there is an election coming up, and we can get them out of office. That's not true with the regional authority. Those members are appointed, and there is no way that they are accountable to the customers. So that was a big concern of ours. We went to other parts of North Carolina, and we learned that in 2008, the city of Wilmington, North Carolina, changed from a city council or a city water system and gave their water to a regional authority. And a lot of things started happening quickly. The first thing that happened is that many customers had their water bills doubled right off the bat. 2 years later, in 2010, the water bills were increased, water and sewage bills were increased by 25%. And then in 2013, every household got another increase of $6 per month per bill. When the customers went to their board, their regional board, and they complained about it, of course, they were basically ignored because the members were not elected, they were appointed. And so the members of the board didn't really care what the customers felt about pricing of water. We saw that happening in Wilmington, North Carolina, and we thought, I don't think that we want that to happen in Asheville. The sponsors of the water bill, and I think we know who they are, Representative Tim Moffitt, Representative Chuck McGrady, and Representative Nathan Ramsey, have said time and time again, it is actually written in the language of the bill to take Asheville's water and give it to a regional authority, that privatization of the water is illegal. Well, we know, you and I know enough to know that bills are changed every day of the week. Happens all the time. Hundreds of bills have been changed just in this legislative session. It would take nothing to change that portion of the bill, to make a regional authority able to privatize the water. Some things happen, well, backing up just a minute. Interestingly enough, in 2013, Representative Tim Moffitt introduced legislation that would create a public-private partnership authority, or a authority act, I should say, or a P3 authority act. Now what this did was it created a partnership committee and an office of public-private partnerships to identify and establish P3s and approve qualified bidders, requests for proposals, and template contracts. In other words, they were meant to recommend what types of utilities around the state could be changed into public-private enterprise systems. Interestingly enough, even though he says that it will be illegal to privatize Asheville's water, the same year that the bill was passed, he introduced this legislation. Yet another coincidence is that this legislation was actually drafted originally 2 years prior to that at an ALEC conference. Now, I don't know if you're familiar with what ALEC is. They call themselves an educational nonprofit. What they really are is a lobbying group. They link up corporations and state legislators behind closed doors where they write model legislation to be taken back to state legislatures around the country and hopefully passed and enacted into law. The laws, of course, since they're written by corporations with the legislators, favor corporations. So this also could have a bearing on whether or not our water would ever be privatized. There's a company in North Carolina and in quite a few other states called Aqua America Incorporated. They are a private water company. They have 3 million customers in 9 states, and one of those states, of course, is North Carolina. North Carolina Aqua customers complain about poor water quality, dry wells, high rates, and inferior customer service. This could be our future if our water was privatized. Some customers and policy analysts say that Aqua favors shareholders over the public good. Aqua North Carolina customers pay as much as $425 a month for their water and sewer bills. These are the highest rates of any private utility in the state. Can you imagine that? Paying $425 a month for your water and sewage? That's a little steep, I think. Aqua also buys and resells water to the highest bidder. Conceivably, of course, they could sell water to a fracking company. That would be their choice. They could do that legally. Aqua actually has a subsidiary that is called Aqua Infrastructure. And what they do is construct and manage freshwater pipelines to carry water to shale organizations, the shale industry. They constructed and manage a pipeline supplying fresh water to natural gas producers in north central Pennsylvania. This is the site where they're having all of the problems with the contaminated water and people's health being negatively impacted. Now, Aqua is not the fracker. They are not doing the fracking. They are buying the water and selling it to, conceivably selling it, and they are actually constructing the pipelines that carry the fresh water for the fracking industry. The Congressional Research Service has projected that national water consumption will increase by 7% by the year 2030, and that 85% of that increase will be attributable to the energy sector. That's everything I have. Again, our website is saveourwater.wnc.com. You can find reams and reams of information about the entire water situation, actually going all the way back, in some cases, to the 1920s, and all the legislative action that has taken place in the recent years. Thank you very much.
Okay, so, in the interest of what can we do, finding solutions, you know, I certainly hope that we don't lose the water system. But in terms of how can you have water that's not dependent on your water system? Here are some more ideas. Well, the tanks, of course, make you independent. But earthworks, as I said before, are structures of dirt or other materials. And so here I have an example of a lawn. And they have a little tree here. It's not doing real well, but here's this lawn, and here comes the storm, and it's going to rain right here on this lawn. And some of the water is going to soak into the ground, and some of it is going to run down the hill and into our container here. So we want to know how much of this water stayed in the ground and how much went down the hill. So lawns only absorb less than 30% of the water. So here we have someone who has put in some berms and swales, some little ditches and hills. The hills are on the downhill side, and they need to be leveled. Back in the back, there's a A-frame level to help you know if you have something level, or you can use a level like this, or, you know, worst case, just fill a pan with some water and see, does it look like it's, you know, equal, or is it tilted? But it's not hard to find out about being level. So here's our storm, and here it's going to rain, 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 rain. So, let's see, this did any better.
Topsoil there.
Yeah, it's too dry. And let's see, picture. I don't know.
Now, even with all that topsoil that normally really wouldn't get in there, that's quite a difference.
So, this landowner had some trees on their property, and so he built some crescent berms, where it's just a kind of a half circle on the downhill side, and you dig it out and put some mulch in. This mulch is very dry also, but you put it about to the drip line of the tree, so that all the water that later on keeps coming down will be captured and slowed down and given a chance to soak into the ground. So here's the storm coming along. And you'll notice I have these overflows that is so that if the feature becomes filled, that we are controlling where the water goes and keeping it from just becoming harmful. So, let's see. Here. So here we have our different examples. So if you would put some berms and swales or crescent berms on your property, they will keep your plants watered. You don't have to keep watering them. They keep the water. Every 3 or 4 days when we get some rain, it fills up again. So another example is going back to the innies and the outies. And here I have some innies. I'll just use this. And, some outies. Innies. And I'm going to have all this rain come along, and not too much of it is going to go into the pan, because most of it is going to stay in the innies. So there's the amount that was with the innies. And here's the amount if we do it with the outies. Not too much going into the ground. It's all going down the hill. So this is to ask you to let your elected officials know we want innies. We don't want outies, because we want the water to go into the ground wherever we can. We have a lot of impervious surfaces, and if our medians were to invite water down into the ground, we could counteract some of the problems that paving and pumping have created. So Dylan's going to give a couple of announcements of some upcoming water events, and we're going to take a short break. We have lots of interesting displays around. Please help yourself. We have some refreshments, and all of us love talking about this stuff, so ask us questions, and hopefully we'll still get to a question and answer period at the end.
Yeah, just a few quick announcements about some upcoming educational events related to water and water sustainability. The Ash Village Institute is putting on the WISE Water School in December 5th through 14th, and there's other outside of the classroom components to that, so it's actually a really intensive, involved program. Talking about a lot of some of these different projects that we're demonstrating here with these models. Ash Village Institute will be running this course that will go a lot more in depth and how you actually make this happen on the ground, what it looks like. And then, along with the Wise Water School, there's also the Water Education Summit, and you can find more information about that at h2osummit.org. Ash Village Institute, you can find information about that at ashvillage.org/wise-water-school. So the Water Education Summit at h2osummit.org, and the Western North Carolina Mountain Stormwater Conference happens October 14th and 15th at the Arboretum. And so I believe you can find out more about that probably through the Arboretum website. I don't have the contact info here. Just to make the point that this is an issue. This is already hot. This is already something that a lot of people are concerned about and doing things about, and learning about, and educating ourselves about. And there's a lot of opportunities out there to get more engaged, more connected with the relationship that we have with water, the way we treat water, the way we handle it, or choose not to, whether we befriend it, ignore it, or treat it like a nuisance, and how that affects us. So with that, we'll just take a quick 5-minute break or so, just to get up and stretch out. You might call it a bio break if you need to use the restroom or get a drink of water or something like that. Take care of your needs, engage with the folks around you, and see you back in about 5 or 10 minutes.
Hey, lady.
Oh, yeah, it's hard.
Okay. So we started out our evening with a lot of overview of some different angles of different water-related issues. And the rest of our program is going to focus largely on contamination. Contamination potential and existing contamination issues and what's being done to address it, what are the effective, where is it working in terms of our community engagement and our public process, and where is it maybe not working so well. So we have a handful of brilliant, talented presenters. But the first amazing, brilliant, talented presenter, it's Sherry Ingram.
Thank you, Dylan. So, as Dylan said, we're going to move into the contamination field now and be talking about examples when our system has worked and when an example of when it's not working and an example of a work in progress that we don't know yet. So, these sticks represent people who have water problems, and they are being destroyed by their water problems. Oops. This is an example of community in action. Can't break it. I can't break it. So, community can mean your neighborhood, your waterhood banding together and emptying your drainage ditches. It can mean, your neighborhood, your waterhood, coming up with a plan to start the highest you can in the watershed to address problems. But most of the time, what our community means is that we write laws and we enforce them. And so, if you care about water, these things can happen to anybody. And so it's important to have good laws in place. The CTS site started being a problem 30-something years ago. And we didn't have as strong laws and people weren't as aware. So when we talk about Hominy Creek, we're going to see this is something that worked. We had a spill, and it's much better now. The coal ash ponds, we don't know. They're in the process of trying to figure out what laws do we need to protect us. And I want to encourage each of you to pick 1 or 2 issues that you care about. Get on the listserv. When they send you an email that says, sign the petition, read the petition, sign it. When they say, contact your congressman, contact your congressman. This is how we put our voices together. And, this is how we make it work. So I'm not very politically savvy or interested. I kind of think of it like changing my sheets. It's something that I know I should do, and so I just do it. And then I can feel good about how good I am. So the other thing that I want to mention is the same concept as starting up high in the watershed. That when there's a point source contamination, that is a place where contamination starts, the sooner we know about it, the sooner we start addressing it, the easier it is. You know, instead of having, you start with a plume that's this big, and then it gets this big, and then it gets this big. And each one of those is more complicated, more expensive, and less effective. So, you know, it's important for us to have laws in place, and that's part of community engagement. So with that, I'm going to give it back to Dylan, who's going to tell us, let us know about Hominy Creek.
Thanks, Sherry. I'm actually going to let Eric Bradford tell you a little bit more about Hominy Creek. But to talk about the coal ash spill in Hominy Creek, we have Eric Bradford. Eric is the volunteer coordinator and clean communities coordinator with Asheville Greenworks, which is an environmental conservation organization working to enhance the community through educational and volunteer-based environmental programs. Take it away, Eric.
Thank you, Dylan, I appreciate that. And what we're going to be looking at today, this was February 14th of this year. This was, wasn't the coal ash spill, but it was a fuel oil spill in the Hominy Creek. And my intern at the time, she put together this really great presentation right after the spill happened, because it all happened really quickly. So she documented everything, got my pictures together. That's why I definitely left her name on her, Christine Brown, up and coming, awesome girl there. So she's really great at putting these kind of things together. I'm better at actually getting out, trying to figure out what's going on here. So I want to talk first about the organizations that were involved in this particular incident on the Hominy Creek. So Thanksgiving Day, sorry. Valentine's Day. Thanksgiving's my favorite, so that's why I'm just glad my wife's not here. So Valentine's Day, we have a spill on the Hominy Creek of about somewhere in the approximate area of about 5,000 gallons of number 2 fuel oil from APAC Harrison Construction, which is pretty far up into Candler. If you're familiar with where Vulcan Quarry is, that far out into Candler, directly into the Hominy Creek. And I want to just talk real quick here about the organizations that were involved in the particular. And as you can see, there was a lot of folks that got involved that particular day. APAC Harrison, the Offender, NEO Corporation, an organization for environmental cleanup, National Emergency Response Team, the Environmental Remediation Group, the North Carolina Department of Environment and Natural Resources, which I believe Chuck Branford cannot be here tonight, but I will speak not on his behalf though. Environmental Protection Agency, of course my organization, Asheville Greenworks, and then we also worked with Western North Carolina's Alliance's French Rock Riverkeeper, Hartwell Carson. Many of these names you already know. So just to take you through the events. So on Valentine's Day, about 1:30, APAC Harrison Construction phoned to NEO Corporation that they had an incident at their particular facility. And basically what it was is an above ground fuel storage tank on their property that if some of you are here familiar with, when you put in above ground fuel storage, you have to have different types of safeguards that keeps, just in case someone comes out and just lets the valve open on it and walks away from it, that there are other safeguards that's going to jump into place to keep this from happening. You're going to have a one, which is a sensor, and two, which is a reservoir system that would keep something like this valve opening and then someone walking away from it and fuel oil spilling straight into a major creek. But all of those systems failed that particular day, which seems to be the case with older systems that are in Buncombe County currently. So someone left the valve open, sensor was not working, and of course the retaining wall around it was faulty as well. So 5,000 gallons approximately of fuel oil was spilling into the Hominy Creek. So NEO Corporation was immediately contacted. NEO Corporation is a for-profit entity, but part of what they do is they have to contact the local government to let them know that they've been called in on something along these lines. So that's the reason why we have this chain of events from here forward. A lot of people think that you can operate in silence. Well, you really cannot. These organizations, they will contact the proper authorities to let them know that they're coming on scene, that there is a cleanup that is in process. About 6 p.m., the North Carolina Department of Environment and Natural Resources was alerted to the spill by APAC themselves, but everyone already knew what was going on by that particular point. By 11 p.m., the all clear was given through the Asheville Emergency Response Team, and that was from NeoCorp. So everything's good to go on Valentine's Day. 5,000 gallons, we're good, we're done. 8 a.m., received a phone call that there was a gentleman who is he's a freelance photographer, was out photographing at Hominy Creek in French Broad, where the confluence is down at Hominy Creek River Park. He was photographing a beaver that had been cutting away at a tree for several months, and he'd been watching this. Well, he's down there, and there is a slick, a constant slick, making its way right into the French Broad River. So he immediately phones myself to let me know that, you know, this is, of course, we're talking about 9.5 miles from the original spill point, that now we have a huge saturation that is shedding down Hominy Creek and then making its way into the French Broad River. So we immediately set to getting people to action here. Phone calls were, of course, made right away to the to media, to Dean or to EPA to find out exactly what's going on here, because, you know, the cleanup was all clear as of the night before. 10 o'clock, both myself and Alliance, we are dubious of what's going on, so we immediately find a private property owner that will let us onto their property. We get onto the Hominy Creek, and then this will begin our adventure from there. So we put our boats in the water and go from there to document what is happening for the rest of the afternoon. So this, if you will, should we bring it a little bit larger right there? I tried to mark it the best I could. So this is a little map, and if you look here, the red circle area, that is the fuel storage tank area. Hominy Creek is in the blue area, it's traveling down, and then the fuel made its way straight through the gravel surface. It didn't travel really so much on the top, but through the gravel surface and straight into the Hominy. That particular route, I'm going to come back to that in just 1 second. This was the scene as soon as we pulled up with our boats. Oh, didn't go in on that one. This is the scene we pulled up. This was to capture 5,000 gallons of fuel oil. We had up on the bank here, we documented every single thing that we came upon and we saw of everything. So we have our petroleum absorbent boom here in the pad. We have the absorbent pads that was there. There was 3 pads in place, a couple of dirty pads up on the bank, and as you can see, it looks like a big white snake. That's just another boom, that just in case we need another boom, we'll just throw it up here on the bank. There is no one here at 10 o'clock. There's no one anywhere around. The entire time we're photographing this, we're talking to this, we're on the phone with Diener, we're on the phone with, Department of Environment and Natural Resources and EPA. Where's the response? Because we're here right now. Here's the photos. We're sending them to you right now. It is an enormous smell of petroleum, of fuel oil here. This is beyond anything. This area is really hard to depict, but the entire, the water coming from this is completely covered in red sheen all the way down. So this is our French Broad River keeper, Hartwell Carson. Some of you know him. He works diligently to protect our French Broad River basin here. And as Sherry mentioned earlier, the Hominy Creek is a sub of the French Broad River basin. So it's a major creek of it. So here we are, 20 hours from the initial spill, 1 boom in the water, and 2 straw bales. So we are flying at this particular point. Fantastic. So we began the trip the rest of the way down the Hominy Creek. Noting everything as we go. There's tests that we're doing along the way to find out how much is being absorbed into the strata, the sand, the organic material. Looking at different pieces as we're going down, and it is honestly too much. It's the smell of it is way too much. It's just permeating everything, every part of us. We smell like we rolled around in diesel fuel. So we make our way down, and while this is happening, while we're making the phone calls and paddling down the creek, the Asheville's Emergency Response Team, which is an amazing group. It is, it's part of our Asheville Fire Department, and it's also with Buncombe County Fire and Rescue with Jerry Behan and these guys. Immediately came out for this. These guys really came out fast. And you can keep in mind, these are firefighters who are doing emergency responses of different kinds. They immediately installed some booms at the Sand Hill. So this is, do you know where the Inky campus is? In Candler for AD Tech. From the phone calls from 10 o'clock to 11 o'clock, they had already installed the booms, that we had requested. So they were in, installed these particular booms here, and we're going down the river, going further, calling Neo Corporation. Why are you guys going back home? We've got more spill in the water. We've got to get back out there. So then everyone started getting back on. Every bridge crossing, we were asking for a set of booms, 2 sets of booms on every crossing. What these booms do, which is really amazing, they're very expensive, but they do this neat little thing where they're hydrophobic. So they're not going to pull up any water, but they will absorb all sorts of different types of petroleum materials. So it's an amazing product, but these have to be in contact with the water. What we found at some of these places was these particular booms were hanging out of the water in a lot of particular places. So this is where our network of volunteers got involved. So we started putting out the call to our volunteers to hit these spots. You see these things hanging out of the water, you put it back in the water, you call the fire department, you let them know you did this. We've got to keep all these covered. Each of these booms have to be covered. I want to play this real quick, and I'm hoping, I can't remember if Hartwell curses in this particular one or not. But if he does, it's Hartwell, it's not me.
And we're at the first boom, which is about half a mile downstream from the spill. Seems like an awfully long way to wait to put up the very first boom to catch a significant amount of oil. But it's the first bridge, just my guess is they didn't want to spend the time and effort to put the hike across the river or a canoe across. So it's definitely catching some product, but you can see a lot of it coming out the other side here. And there's a significant amount of oil coming down, again, like 20 hours after the spill. So a lot of sheen.
So quickly, and I did bring our benthic macrovertebrates back here, so if you have a second, I want you folks to meal through here and check out some of these bugs, the base of our food chain in our water, and they're also the canaries in our particular coal mine as well. So these are the ones that we're going to start searching for. We're going to start looking for these guys to see who is directly impacted by this. Because the sheen on the particular top part of the water is, if we have some really hot and sunny days, it's going to burn off for the most part, which is great. But we also have to be very aware that these types of insects are going to be incredibly sensitive to these particular ones, and especially the ones where the petroleum products is getting into the leaf packs, soaking into the biomatter that's there. So then, from there, this is what we did. This is the part of the testing that we've done over the last few months since that fateful Valentine's Day, is checking on our macroinvertebrates. And we'll get to just in a second for that. So the direct impact of these sort of things is you got to look at a couple of you got to definitely look at the macroinvertebrates to see what's going on. They're the base of the pyramid supporting the rest of the food chain, but they also tell us what's going on with it. Next up from there will be our amphibians. Then we dip over into our fish. But the ones that would be the ones that would probably make the news right away would be the animals that are in the water the majority of the time, which would be our beaver and river otter that are traipsing about the water. So that is a huge concern for us. I will end this in a positive note. There was, as much time as we spent on the Hominy Creek over the last few months, we've seen no fish kills. We have seen no large animal kills. Our macroinvertebrate studies that we've done so far have shown a positive rise in macroinvertebrates. And there's a tolerance sheet back here as well I want you to look at, because some of the macroinvertebrates can survive in really high pH in really dangerous places, and a lot cannot. And we're finding our ones with very low tolerance are thriving right now in the Hominy Creek. And what I'd like to give that credit to is because of the response. And the response, 90% of the response that came out to this Hominy Creek incident was volunteers phoning us, wanting to get involved. People who were saying, this is out of control, I see that the news is somewhat involved in this, what can we do to help with this particular situation? So the reaction that we had from everyone coming out this particular weekend was absolutely astounding, because these people are the ones that helped us do this. These people are the ones who came out and helped us do subsequent testing afterwards. We're a small office, only 6 persons in our office and 12 interns, but we need that army of our volunteers to come out who do want to get involved in the community, and that's what they allowed us to do, is to do the testing, the monitoring, and the follow-up from there on. Actually, we went out and we tested again, what was it, the 28th. So we've tested one more time right before this study, and we look great. It's all burned off at this particular point. We've removed some large organic GMs and leaf packs. There's no residue left over, so there's some really wonderful things there. But I want this right here. This is my favorite thing that happened. So our friends from EPA, they rode up from Atlanta. That is our regional office for Environmental Protection Agency. They came up on Saturday after the barrage of phone calls, to get them up here to do the response. You got to know these guys were also coping with the Dan River incident at the same time. So there was 2 issues going on, but they did give it enough credence to get them out. But this was the first interview that we were able to get, and we got this interview by hook and crook. So we kind of didn't give them a lot of options. This was a late Sunday. Everybody was tired, smelling of oil. But we were able to get our gentleman here to answer just a few questions for us, and bear with me on this.
We have Terry Stillman with the Environmental Protection Agency, with WC Alliance's French Rock Riverkeeper Hartwell Carson. Going to answer a couple of questions about the Hominy Creek fuel spill.
Yeah, Terry, can you tell us what's happening right here below us? We're at the Pond Road Bridge, and I'm just curious to get your description of how the system's working and what you guys are doing to help recover some of the oil in the creek.
Okay. Sorry about that. Okay, so what we have 6 separate locations along the creek where we have a hard boom, which is a kind of a buoyant plastic material stretched across the creek, and in front of that is a sorbent boom. And what we're trying to do is collect any oily sheen that made its way from the original spill site, and we periodically come and take a look at to see if there's any recoverable oil, any recoverable sheen. So we'll come every few hours to put down some sorbent pads and or change out the sorbent boom.
And that the pads will help pick up the thicker oil product?
Right. The sheen itself is really not recoverable. Over time it gets burned up by the heat of the day and the sun. But by putting out the boom, we're able to kind of collect everything and sometimes get it to gel together, and then we can pick it up.
So the public's been seeing a lot of the sheen. How much, it sounds like they're going to continue to see that for a period of time. Do you have a guess on?
It's hard to say. Certainly over the next few days, you're going to continue to see sheen, especially in the creek. Our assumption is that we're going to keep the boom out. We're going to keep on doing what we can to collect what we can, and it should start lessening. We're also going down the creek from the spill site and inspecting the banks to see if there's any. Sometimes there are natural collection areas, little coves where some of the spilled oil might have become entrained. And we're trying to pad that area up or collect that area. We're doing that today.
And can you describe sort of what the sheen is versus what sort of the heavier product is, and maybe how effective the booms are at removing those two?
Well, the sheen is very light material. It's right on the surface, and sometimes it's described as a rainbow sheen. Sometimes it looks a little thicker. The original oil itself, if you've seen it, looked almost kind of red in color because there's actually a dye put into it.
Yeah.
So it's certain types of diesel fuel or dye, or not dye in this case. By regulation, this was dye. So we don't see that anymore. A little bit when we can get it to gel together or coalesce together. We'll see a little froth that looks a little somewhat red.
And that's good that you're not seeing that, correct?
Right. But we're still going to maintain the boom. We're still going to keep it in the creek for a number of days to see what we can do.
So when the public sees the sheen coming past the boom, is that normal? I mean,
there's a certain amount because it's so light. There's a certain amount that is going to get past the boom. That's also why we have boom at different locations. We don't just have one set of boom out, not two. It's 6 different sets, and we're just going to keep working along the bank, and keep maintaining these booms to see, at some point it should start lessening.
and you'll wait and you'll look and see how much you're getting to decide when you're going to remove the booms altogether?
Of course, yes.
Okay.
And we work with the state of North Carolina to make those determinations also.
Okay. Any other important things?
Is there a contact number, Terry, that anybody can call if they have concerns for the public?
I don't have a general contact number.
Okay. All right, well, thank you.
No, there is not a general contact number. So, one thing I like to quote, and I quote it often, and this is something that the Waterkeeper Alliance says often, is dilution is not the solution for pollution. It worked in this particular instance, they got a pass. They got a pass because there were an army of volunteers putting the booms in the water, monitoring, calling back, what's going on here, taking samples at different places. Then the subsequent follow-up work, going back to the creek and checking, testing with us, making sure it was okay. These guys got a major pass this particular time. We are not always this fortunate to be in this particular type of situation. The Dan River incident, which we could possibly have coming up here, and Emma's going to speak about those sort of issues, is not going to be fixed this easily. Not by a long shot. So something like this, we got a pass, but we wouldn't have gotten this pass if it wasn't for the army of persons just like yourself who wanted to be on that listserv, like Sherry mentioned, to know when this sort of thing is happening and they can get out there immediately to make a difference in their community. So I'm going to cut this a little bit short because we're out of time, but I will be taking questions at the end. So thank you everyone for your time.
Thank you. Are you going to have a PowerPoint? Yeah. So hopefully, thanks to Eric, you know that there was not a coal ash spill on Thanksgiving Day, but in fact a fuel oil spill on Valentine's Day. Or Thanksgiving. Sorry for that.
Coal ash spill is Super Bowl Sunday.
Super Bowl Sunday, so we got holidays left and right. So our next little segment here, we're going to be discussing the CTS site. And so we have a couple presenters talking about this. The first is Jeff Wilcox. Jeff Wilcox is an associate professor in the Department of Environmental Studies at UNCA. He teaches courses in groundwater and surface water hydrology, water chemistry, physical geology, and introduction to environmental science. And he's going to talk to us about water contamination near the CTS site.
All right, well, thank you for sticking around. And I could talk for several hours, but I won't do that. I can keep it to a couple take-home messages for you. Let's see. Most of you are probably fairly familiar with it, at least from reading the news or watching the news. It was a former electroplating facility where several different volatile organic compounds and heavy metals were released. The volatile organic compounds basically means that they're organic compounds that, when exposed to air, will volatilize into the air. So when you go and fill up your gas tank and you smell some of the gas, those are volatile organic compounds that you're smelling. In 1991, it did not qualify in its first round for Superfund National Priorities List designation. If you'd like to hear me talk for a long time, you can ask me afterward what mistakes were made in that initial scoring, because it is now on the NPL today. One of the reasons was that initial site inspection and report failed to notice or report that the springs on the sort of southeast side of the site actually were used to feed groundwater, or to feed the surface water that was emanating from the ground into the surface water and to residents living right near there. The residents in 1999 collected their own samples, and this does not seem to be advancing. Is there a button on? Oh, there we go. Okay. They did their own sampling and then brought in NC DENR and eventually EPA, where they found the levels of TCE in the water emanating from those springs were as high as 21,000 parts per billion. TCE is a carcinogen, and the drinking water standard is 5 parts per billion. That was water that was being piped straight into households for drinking water, washing, baths, showers, hot tubs. There was a hot tub that was filled with water containing potentially up to 21,000 parts per billion of TCE. The residents were immediately given bottled water, and city water lines followed very shortly. This is a picture that I pulled from one of the geology textbooks, hydrogeology textbooks that I use in my courses at UNCA. And this shows what happens when you have organic contaminants like TCE. And so, in many cases, you may have a barrel that is leaking. I'm going to use my hand because I don't have a pointer. And what happens is the organic compound falls through the soil. Some of it sticks to the soil. When it reaches the water table, some of the oily compounds that are lighter than water, you may have heard a term called LNAPL, that's been in the news a little bit later, or a little bit recently. Some of the compounds that are lighter than water tend to kind of pool up on the water table like this, while those that are denser than water, DNAPLs, sink through until they reach something, whether it's a bedrock surface or some sort of low permeability unit like a clay, they can kind of pool up at the top of that. This is also what we have going on, thank you, Rick, at CTS. How do I know that? Because I read some of the reports. This is a cross-section from one of the reports from 2004, and to give you a little indication, here's the building, the CTS building. Here's the subsurface. These are the springs that I talked about with the 21,000 parts per billion TCE in 1999. This is a 2004 report from CTS's contractor, and they noted they found 280,000, this is, you can think of it as parts per billion in the soil, above the water table. They found 400,000 just below the water table, and as high as 830,000 kind of pooled up right here on the bedrock surface. And I think I noticed the date here, 2004. Sherry, thank you for inviting me to speak today. You mentioned earlier it's important to get at the source when it's a point source contaminant before it spreads and the problem gets bigger. This problem actually predates 2004 by about at least 30 years. But of course today it's 2014, and unfortunately I'm going to show you that not a whole lot has happened since that time in terms of actually cleaning it up. Certainly not as fast as the Hominy Creek. You're talking about days of cleanup, oh my goodness. So in 2004, MacTech proposed some alternatives that could excavate the source area for a cost of $5 to $5.5 million, or they could do this, what's called soil vapor extraction, for a little bit less. And which one did they choose? A little bit less one. And soil vapor extraction is basically taking some vacuum cleaners and putting them below the surface to suck out the gas, the air, as the TCE is volatilizing, it sucks out the air. This is a very commonly used treatment for volatile organic compounds. The main problem with this is that soil vapor extraction can do a very good job of cleaning up shallow soils above the water table. And they recently published a report that demonstrates, at least in some cases, it was effective at removing some TCE from the soil. But does anybody remember where that 800, oh, it's right here. That 830,000, I remember where it is, right here. So the soil vapor extraction system may have been effective, but it didn't get at the source of the contaminant. And if there's one thing I hope you leave today, you know, if you're asked about the CTS site, you say, they've got to get the source. Because until you get rid of the source, you're going to constantly have new problems cropping up in new places, or at least the potential for that. This is a map looking down at the building, and right on sort of the southern edge of the building, this was where they drilled down to get to that 830,000. So the previous slide, you're kind of looking at it from the side, and this side now you're looking at it from the top. Well, they went and drilled it again within the last year. They drilled a point to within 4 feet of where that 830,000 was. When I got a copy of the report in May, I flipped through, it was 1,100 pages, but I was looking through and I knew they were drilling that point. I was like, where's the point that corresponds to 830,000? And sure enough, there it is. There's their point. This is the 2014 report, released in May. 1.1 million parts per billion. Now that sort of makes sense. TCE is heavier than water. So actually, if you let 10 years go by, what's going to happen? It's pooling up more or less right at the surface of the bedrock. You have 830,000, and by the time you get to these high numbers, the error and the actual number is pretty high anyways. But what's going to happen is over 10 years, more TCE is going to sink through the water table or sink through the groundwater until it gets near that bedrock surface. And again, that was very recently. So this is what we've got underneath the site. We've got some contaminant in the soil. We don't have a barrel. There are no barrels under there. They were, I like to say it's TCE without a barrel around it. But we have some at the surface of the water table. We have some in between. We have some pooling up down here where the 830,000 is. And we also have some that as fresh groundwater flows through here, it pulls a little bit of it away. And by a little bit, it might be 21,000 parts per billion, but that's still mostly water. And so what this represents here, all of these dots, are what's called the dissolved fraction, where some of the TCE moves with groundwater. And here's a map showing, again, the CTS site, and it shows where groundwater is flowing. Right here, beneath the site, to the springs, to the southeast of the plant, but also up here to a contaminated creek on the northwest side of the site. So there's actually a groundwater divide. If you drive down Mills Gap Road, you'll see that there's lower points on either side of CTS. That was July 2009 report. I got involved because I teach at UNCA. I have estimated 250 students or so have walked around the site, have walked around the neighbor's property, and I teach a geochemistry class, and what a better place to talk about how to collect samples, analyze samples, write reports, and I guess behave properly in these types of situations. And so we began collecting samples of this string of leaves from the contaminated springs, and what you can see is by the time it gets, oh by the way, they stopped the access to the contaminated streams with a chain link fence. The problem is the chain link fence doesn't really stop the water from escaping. So if we go right up to the chain link fence, by that point the 21,000 is down on the order of 1,000 parts per billion. If you go just across the road, across Mills Gap Road, you get to below, 140 parts per billion. And by the time you get just a little bit down Concord, it's actually not detectable by the time you get here. So what's happened to it all? It's in the air. It's a volatile organic compound. So why does it go from 21,000 here to 1,000 to 0? It's all going up into the air, and some of you may have seen the news within the last, I guess it was toward the end of May, when the residents, it was in June, first week of June, that the 13 residents were evacuated because of the air quality. And so it actually is a carcinogen both to drink and to breathe, the vapors. The last thing I'm going to say about this is we've got our source beneath the site, we've got our dissolved phase that's traveling away from the site, but we've also got some of the source sinking in to the fractured bedrock, which we have all throughout western North Carolina. And Rick has studied the fractured bedrock a fair amount. It's a very complex system. He actually worked on a project, his team worked on a project near CTS, and so did a USGS team. And I cut Rick's out for time purposes. I apologize for that. But the USGS, and in combination with some of the state's work, very conclusive. What they basically were able to do is look through some test wells, and they were able to map the direction of the fractures. And the fractures were aligned in this direction. So each one of these blue lines refer to how many fractures or what percent of the fractures were aligned in that direction. And one of the things you notice is that the fractures are aligned roughly northeast to southwest. And if you look at where some of the contaminated wells have been found, that's almost, it's about as conclusive, in my opinion, as you can get looking at fractures to show that the source of TCE found, this is in the neighborhood of the Oaks, come from CTS, which is part of the reason these residents in the Oaks got water lines following the detections in 2007 and 2008. And some more residents are in line to get water lines now. I should say paid by Buncombe County, not by CTS. So my take-home message here is that until the source of TCE, this still resides underneath the plan. Until that source is addressed, we're still going to have potential threats of air, groundwater, and surface water quality. This has already lasted decades. The source will still be there decades from now unless the source itself is removed. So whenever I've been asked to speak about this to whatever group or organization, I've said the same thing. I've been very consistent that the source needs to be removed. I wish in 2004 when the SVE system was put in, I wish they would have addressed the deeper source beneath the site. But if you go home today, I hope that's what you'll say. And I'm going to one of the community groups. There's several different people within the community, and one of them is Leanne Smith, who's going to speak next about some of what it's like to organize a community group. It was right here. It's thinking. I was just pressing enter and worked best.
So, this is, as Jeff pointed out, there's very high levels of these contaminants. And what I'm here to do, as I told Sherry, is to just very quickly put a human perspective on it. A lot of people, many people have been affected. And anyway, I'm going to just tell my perspective. My son's back. So, my son Gabe, who's the one on the far right in front, was 11 when he was diagnosed with a rare form of thyroid cancer. And the oncologist asked if we'd ever been to Chernobyl. She knew we had traveled some, and we said, no, that wasn't our family vacation fun spot. So, but what happened was it got me thinking about why did she think there was something environmental? Because there was no family history or genetic predisposition. He had surgery, and that's one of few pictures I have of that time. His baby cousin was born about the same time, and he was able to be motivated to get up and help him. The cancer had metastasized, and we traveled to another area to be treated. And it was and remains a very difficult situation. And several years later, his younger brother was diagnosed with a bone tumor in his leg that that one turned out to be benign. And when he was, as I call it, on his healing path, we learned about this. We drove past it almost every day and didn't know a lot about it. And then started asking questions and found out, as Jeff was saying, some of that information with the CTS side. And so we decided to become involved. There we were just a few years ago. And let's just look at pictures. There was an executive with CTS named Mark Goebbels who had declared the site clean, and he was not licensed to practice engineering in North Carolina, nor had he ever been. And we were able to obtain a couple of years ago a cease and desist order against him, and just right after that he resigned. And we redeveloped communication with the EPA. That's been a very challenging situation, but we, in an effort to hold them accountable to what is their mission statement of protecting human health and the environment, we sit down at the table with them and talk things out, and often butt heads, but we want them to know that we're very involved and interested in what they're doing, and we expect them to do their jobs. We've been fortunate to have the support of Clean Water for North Carolina and the Alliance. They've been wonderful supporters for our work and offered great guidance. And we founded this nonprofit, which stands for Protecting Our Water and Environmental Resources. We applied for and received a technical assistance grant. We developed a petition to calling on CTS to do the right thing and get the site to come in and clean up the site. And we're thinking about other things. So, and we don't plan on giving up. And there's my son a couple of years ago. And so just to put a little bit of a human face on it.
Thanks so much for that glimpse at the real impacts, the real implications, and the emotional impact. Do you have a PowerPoint?
Could you have a PowerPoint? Okay.
Find that.
While they're working on that, I want to comment that, this can happen to anybody. I've worked in the environmental industry for 15 years, and, when a problem starts out, people are completely unaware. And as you start to understand more about what's happened there and information starts to get out, of course it's the people that are closest that are, immediately impacted that are going to stand up first and talk about it. But, it's so random. It's something that can just happen to anybody. So, when it falls your lot to have this type of a challenge, it's really, really helpful to have people from outside of that immediate area step up and say, this is important, and this needs to be addressed. Part of what's changed is the regulations over time. They were a lot weaker then, but they're still, CTSI is still trying to get some kind of justice for it. they can't even move forward because of the Supreme Court ruling. They can't even move forward and remove the source material and then sue CTS. So, you know, it's really challenging.
Thank you, Sherry. And I'll just
Okay. My name is Emma Greenbaum. I'm the organizing representative for the North Carolina Be Not Coal campaign for Sierra Club. So we're going to be switching gears a little bit to a different type of contaminant that is also causing health problems for folks across Western North Carolina and the rest of the state. And thanks for hanging in there for everyone here to stay. So there's a lot of ways to say coal ash. So just keep in mind that when you hear, if you hear coal combustion waste, coal combustion residuals, that's also coal ash. That's sort of the most common term now is coal ash because more folks are hearing a little bit about it. And the impoundments are called ponds, lagoons, or sometimes surface impoundments. We tend to call them coal ash ponds. So what is coal ash? Coal ash is this stuff that's left over after burning coal. So it is a toxic laden waste that's left behind after we burn coal for energy. And coal-fired power plants in the U.S. produce about 140 million tons of coal ash waste every year. So this stuff it's kind of a soup of toxic heavy metals. So this is just, I can't remember what somebody called a cartoon earlier, but it sounded really good. But this is just a little cartoon of how this stuff works. So coal is burned, and then the stuff that's left over. Well, okay, so there are a couple different things that happen. So when stuff gets released out of the smokestacks, one of the things that's actually helped our air quality is putting scrubbers on our smokestacks. So after the Clean Smokestacks Act in North Carolina, we all got to breathe a little bit easier because the sulfur dioxide and nitrogen dioxide was no longer as heavy a concentration in the air. But when you pull that stuff out of the air, it does not just disappear, unfortunately. What happens is it goes into those air pollution control filters or scrubbers and then concentrates it even more in the coal ash ponds. And then the ash ponds are then leaching both into the groundwater and into the surface water. So these coal ash ponds are really quite rudimentary. This is pretty much just a hole in the ground. So this wet stuff is sitting in a hole in the ground, and we've learned a lot about water and how water works over the course of this forum. So as you might imagine, it is contaminating both our groundwater and surface water. So these are some of the health effects of some of that stuff that is in coal ash. So there's arsenic in this stuff, which causes multiple types of cancer and other difficulties. Chromium is a known carcinogen. Lead is another one, decreases in IQ, nervous system, developmental and behavioral problems, and mercury, selenium. Another one that is not included in here is thallium, which is also a suspected carcinogen and is odorless and tasteless, and you can absorb it through your skin. So this stuff is not just harmful for human health, so it's also detrimental to our precious ecosystems here in North Carolina. So we worked with a number of partner groups, including the Water Keeper Alliance, and helped fund a study on what selenium poisoning is doing to fish in Sutton Lake. So if you can see, this is a bluegill in Sutton Lake, and this over here on the left the power, okay. This is a normal fish here. He's got his little nose that he can eat with. And up here, these guys have a deformity that's called pug nose. So basically it makes it so their mouths are smaller and they're not able to eat as well. And over here, this is a bluegill with a deformed spine. So this is how it should be. And this is the deformity from selenium contamination. And the problem with selenium is that even if the water levels are not particularly high, the stuff bioaccumulates. So I put especially the selenium poisoning one, just to highlight that it does not take a spill for there to be coal ash contamination in our waterways. But sometimes spills do occur. So I'm guessing folks have heard about the Dan River spill that happened actually on Super Bowl Sunday of this year. So what ended up happening was about 50,000 to 80,000 tons of coal ash were spilled directly into the Dan River. What had happened was there was a storm drainage pipe running underneath the coal ash ponds, and it turned out that Duke Energy didn't actually know what it was made out of. They thought it was reinforced concrete because the sort of end of the pipe coming out into the river was a reinforced concrete. But in fact, what was running under the coal ash ponds was corrugated metal that was much flimsier. So that ruptured and poured all of this coal ash down into it and directly out into the Dan River. So the Department of Environment and Natural Resources did some initial testing and said that the levels of contaminants were fine. But we were working close. One of our coalition partners is the Waterkeeper Alliance, and they do a fantastic job of some of that rapid response stuff, like our French Broad River Keeper here. So they were on the ground within 24 hours doing their own testing, and those levels came back significantly higher. And this site, just to make you guys aware of it, was just about 6 miles upstream from Danville, Virginia's drinking water outtakes. So this is Waterkeeper Alliance, a photo from Waterkeeper Alliance. So those are our folks out on the river doing testing, and that gray plume is all coal ash. So the river should be that brown color, and that's all coal ash directly from the stormwater pipe. This is an aerial view of the coal ash pond. If you can see, this all here is where it's drained down into the pipe. And just for a sense of scale, these down here are pickup trucks. So this was a huge spill. So there was a lot of back and forth, and there was a ton of media happening right after the spill. It made national news multiple nights in a row, and it spurred a federal grand jury investigation of Duke Energy and the Department of Environment and Natural Resources, and they found, in fact, Duke and the Department of Environment and Natural Resources had been talking very closely about the coal ash issue. So hopefully this will work. So this again is just an illustration. This is a video that one of our partner groups, Appalachian Voices, put together after they've done some organizing around the Blues Creek plant. So this again is a demonstration of what can happen around a site that hasn't actually experienced a coal ash spill.
My name is Annie Brown. I'm a lifelong resident of Stokes County. I've lived in this area since 1950. And I started getting sick when I was 22. And I love to turn the switch on and have my lights just like anybody else. But at what cost? You know, if I had known that stuff was toxic, I wouldn't be living where I'm living now.
In 2005, I moved to Washington DC, and around 2010 I started to notice that a lot of people back home in Stokes County were really sick and dying of cancer. My mom's cousin had this mysterious leukemia. She died within 2 weeks. Danielle had been diagnosed with a brain tumor, and I knew she didn't smoke or didn't drink, and I just thought that was really strange that someone my age, so young, would have cancer.
My name is Danielle Bailey Latch. When I was 35 years old, I was diagnosed with stage 3 brain cancer, and that was in 2010. I've lived in Walnut Cove in the Stokes County area near Pine Hall Road for 20-some years at least. Never expecting to become sick at age 35 and given a expiration date of 3 to 4 months. But now I'm in remission, but the unfortunate thing is, even though I put that behind me, I'm starting to make a connection. Something is not right.
I do not feel that the state is probably keeping tabs on it, the contamination that we receive here in the water tables and also in some of the ash pits we have in the local area. Possibility of the wet, the coal ash getting into the dam milk is a possibility too, contaminating the fish and also the river. It's very close. I mean, it's within 100 feet.
I'm Dr. Deborah Cowan. I'm a veterinarian here in Stokes County. We have lived here since 1993. One of the things we have noticed over the years is back in the early 90s when we first came here, we used to see a lot of Canada geese landing on the pond. And some days you could go out there, there'd be, I don't know, 30, 50, 100. And as time has progressed, you see none.
I'm concerned about wildlife, little wildlife, but I love human life as well. And I have children, I have grandchildren, and I even have great-grandchildren. I'm a young great-grandmother, and I want them to be able to have a life that's free of constant problems that's caused by toxins, you know. I'm concerned about them.
This is the Asheville coal plant. You can see that the water that you see there is Lake Julian, and those are these two are the old smokestacks, and this is the new one with the scrubber, again, taking a lot of that stuff out of the air, which is great, but then making it a bit more concentrated in the coal ash pond from this huge pile of coal. So these are our coal ash ponds. And if you can see, this is part of the impoundment. Down here is the highway and then the French Broad River. So this stuff is seeping directly out into the French Broad River. This is actually rated a high hazard site because if this earthen dam were to be breached for some reason, say abnormal rains, it would almost certainly cause a huge catastrophe for our local ecosystems and the loss of life. So we work with, again, Hartwell Carson, French Broad River Keeper, and he was one of the first folks to sound the alarm about the coal ash contamination in the French Broad River. And there's well-documented contamination of these toxic heavy metals that I've been mentioning. So this is kind of where we're at on coal ash after the Dan River spill and after all of this has come to light. So really, again, what I want to drive home is that although the Dan River spill sort of thrust this into the consciousness of North Carolinians, we've known about this contamination for quite some time. And Duke has known about this contamination from sites that have not breached for quite some time, as has the Department of Environment and Natural Resources. So So this was just a few weeks after the Dan River spill. We had a coal ash petition delivery. Ourselves, along with Appalachian Voices and Greenpeace, had sent out an action alert to all of our folks across North Carolina, and we delivered thousands of petitions to Duke Energy. We actually had about 150 people outside Duke headquarters at like 9 a.m. on a Tuesday morning. So there was huge outcry about this, and that standing in front of the North Carolina sign is Marianne Hitt, who is our national director for the Beyond Coal campaign, who came down to speak at that rally. These folks on the left are from Democracy NC, who also got involved in the cause, and Amy Adams over on the right, who actually used to be employed at Diener, and when there was a pretty big shift in the department towards making sure that businesses could do business in North Carolina, regardless of what kind of contamination they were going to bring to our ecosystems, she decided to quit and go work for Appalachian Voices. And she and her daughter just came with us to the EPA hearing in Atlanta on Tuesday and testified that we want strong protections on carbon emissions. So she is kind of a rock star. So this is sort of late breaking news. So after the Dan River spill and after folks started to take a lot of heat for the coal ash issue, even some legislators that are normally not friendly to our cause but realize that this is really important, there was pending legislation on coal ash. And just today, as the legislature is adjourning, they came to a deadlock on the coal ash bill. So basically, the Senate and the House could not agree on how to deal with this issue. I have mixed feelings about this, partially because it's not good that we have no bill, but it's certainly good that we don't have a bad bill. So there are some things that can definitely be improved upon, but this will be something to keep your eye on. So what can you do? This is all focused on what you can actually do. So please write down these numbers, put in calls to Senator Apodaca and to Representative McGrady. We need them to improve on this coal ash bill, because this is a problem across North Carolina. This is affecting people's health, and this is our opportunity to actually have an impact on it. This is the biggest opportunity that we've had on coal ash since we've had coal ash incumbents. So please take a minute and call them. And right now, the EPA is in a comment period for potential protections on carbon emissions. So what that's going to do is it's going to allow us to start moving off of these fuels that are so toxic for our environment and onto cleaner energy solutions. A couple folks came with us. Kathy came on Tuesday to testify. And we also have comment cards at the table at the front. Please sign them and leave them if you're interested in this issue and if you'd like to speak up. So thank you so much.
Thank you. And bringing it to a head here, Sherry's going to tell us just a little bit more about the Water Sustainability Initiative here in Asheville.
Well, and what I'm going to be doing next is talking to you a little bit more about these measures and how you do them.
Sorry, is the lights on or off?
Yeah, off. So as I said, these measures can be helpful to avoid drought, and they can be helpful to avoid floods. when Rick was talking about the soils being waterlogged, when you have moist soils, it keeps from having waterlogged soils. The pressure in the soil is low, even though it's moist. So when you have very dry soils and then you put a whole lot of water in there, is when they get too heavy and then they slide. So, So I wanted to talk some about particularly the low-tech methods. I like the low-tech methods because they're cheap and available, and I want people of modest means to know that they too can do this. And you don't have to hire a landscape architect or an engineer in order to start doing these things. You can do them independently. Unless you have 10,000 square feet of property that you're going to have change, you don't need a permit, you don't need anything except just go scrape up some dirt and make some piles. So, but there are a few other methods. Plunge pools, when at the bottom side of a pipe in the ground that you go over, the water comes through really fast and it wants to lift all that dirt up and wash it downstream. So if you just put some concrete blocks or big rocks or something like that down at the bottom end, then that can really help. We've talked a little about berms and swales, plants and trees. Aeration just means, lifting the dirt and letting some air get in. Mulch we've talked about. French drains are usually, they have some material in them to keep them from collapsing. But I'm going to go through these measures. Check dams, water goes over and through them. They slow it down. You put 2 anchor points across the gully, and you can put any kind of yard trash. You can use, they have these check dams that are made with large rocks. And over time they'll collect leaves and seeds and can be used in a series down a hill. So if you have an embankment that is eroding, you can put some check dams, alternate them, and slow that water down and keep it from being a problem. So infiltration basins, mostly around trees or other vegetation. You have to be sure that the berms are level. Scrape some dirt from around the tree to the drip line, form a little hill around it, add some mulch. Not too hard here. You see that tree over on the left doesn't have any mulch. On the right, that's adapting this basic concept to being downhill, so it's a crescent berm. I've also found that maple trees in particular have very shallow roots and they don't want you to scrape the dirt, so you can put a trench around. But the idea is to get the concept and use it where you live. Diversion swales, just move water from where you don't want it to where you do want it. Over on the right, there's an example, like the little model that I showed you of having water, give it several chances to soak into the ground. You want to stabilize these sometimes with rocks. And contour berms and swales, again, it's important that the berms be level so that they don't get broken by the water. Mark your level contours using your A-frame level or some other method. Dig along the swales, pile the dirt on the downhill side, add some plants. Not too high-tech. These are some of the mid-check methods. I'm not gonna go through those, but, those are available. You can do yourself or have somebody do them for you, and the high-tech methods. So economic benefits to residents include that you have a water source outside of the municipal system and wells, so that even if the water system were taken over, you would have a source of water for your property. Be able to avoid rising water prices, protection from floods and droughts, knowing your waterhood, the people that live around you that share water with you, increase your property values, increase your crop and garden yields. Economic benefits to utilities, reduce the strain on infrastructure. They're really trying hard to keep up with what we need, and you know, we have this continually increasing population that makes it really hard to catch up. Lower energy costs for utilities, flood control, reduction of solid waste, and having a backup source to the municipal system. Finally, to the region, there would be new local jobs of companies that would do these things, safeguard tourism with ecotourism. At some point, energy prices are going to rise enough to affect people being able to travel and go visit. And I worry about how that will affect the tourism industry, and I think we could bolster it by letting people know that Asheville knows how to have sustainable water, improve our water quality, protect our watersheds. So there are a lot of advantages, and I hope you'll take these to heart and go make you some berms and swales. Dylan?
Thank you, Sherry. So, unfortunately, we've gone a little over our time, which I always view as a really positive thing. Whenever I see a group of speakers go over time, these are so knowledgeable and passionate about what they're speaking to, that they just can't contain it in 5 or 10 minutes or whatever. And so we had a whole lot of great content here. And so we're not going to go into a formal discussion forum, Q&A kind of thing, just for the sake of respecting everybody's needs to be wherever they need to be tonight. But I imagine we could have an informal, more casual, kind of social interaction here afterward. But just a couple of quick things. I just want to make sure that I thank all of you for coming here, for participating, for being here, for caring. I want to thank all our great speakers for presenting. Let's give them a hand. I want to thank the Western North Carolina chapter of the UN, I always miss, United Nations Association, Western North Carolina, for co-sponsoring, helping us out, helping us get the word out on this, and get it, help you all find out about it and get you in here. I want to thank our friends at Lenoir-Rhyne Center for Graduate Studies for the use of this space, and all my friends in Transition Asheville for helping to support and coordinate this. And especially I really want to thank Sherry Ingram. Sherry almost single-handedly put this whole effort together. She's been working on this for months. She cares a lot about this. She's been working on the Water Sustainability Initiative for several years now, and she's just been going and going and going and really cares enough about this to just keep doing it, keep moving it, keep pushing it forward. So I really want to just thank you so much, Sherry, for getting us all together in the same room, and getting all these people with all their great information and their knowledge and their resources to share and exchange all of that. It's really beautiful. Give yourselves a hand for coming too. Thank you. And good evening. And don't forget that there are all kinds of demonstrations and things to sign. And yeah, thanks. And the petition, if you did not get a chance to sign this, I'll set it up.